Hi everyone, welcome to my YouTube channel TechDataEngineer. So in previous video we understand how our streaming works, how we are setting up the Kafka offset, how reading data from the Kafka offset, and how broker works, how zookeeper works and all. So in this video with the simple use case we will understand how we are reading the offset, how checkpoint location getting mentioned, and how we are recovering our job, how we are continuously running our job in case of streaming. Okay, so we will see all this point and all. Okay, so in PySpark, so in this basically in this example what we are doing, there is a finance IT offset. Okay, so we are reading that offset and then we are writing back to the postgres db. Okay, so this is the dummy everything connection and all, so I have kept it, and so we will understand first. So first step is to read data from the Kafka. So you need to configure the Kafka read stream. Yeah, obviously you need, if you are reading data from Kafka, so you have to write like a Spark read stream. So functions to read the Kafka topic. So Kafka stream come with the object. So Spark manage them with checkpoint location. So you need checkpoint location so that if your job getting failed or if you are stopping your job again you are reading, so you need to read the latest offset or earliest offsets. You need to see based on that. So that's why we require checkpoint location. Okay, so processing the data. So after reading the data you may want some transformations or some filter conditions to process your data. You can write it, then write data to the postgresql. Okay, so you will write the process data back to postgres. So this involve for each batch function. Okay, so for each batch function, because this is the streaming data, we are reading a streaming data, we are doing manipulations, we are doing transformation, and while writing you have to write by each batch. Okay, to handle the micro batching. Okay, while writing the macro batching, then enable checkpoint. So as we understand, to keep track of processed offset and allow for recovery. So suppose there is a 1 to 100 offset and we read data from 1 to 50, and after 50, from 51 we stopped our job, a Spark job, because this is the continuous job, right? Then again we wanted to read the data only from the 51 to 100. We'll write based on either earliest, like offset equals to earliest or offset equals to latest. Okay, based on our rate. So that's why we required checkpointing also. Okay, so now understand the code. So simple, again we have imported PySpark SQL Spark session, then expression, then a string type. We have created a Kafka to Postgres Spark session. Then we have defined. So these are important. We have defined. So this credential you will get it once you are writing the job. So you need to take it from the Kafka team, like Kafka broker. What is the broker name? You can write out. So this is, so I have written everything is a single code. But if you'll write some production level job, then you have to write it all this into config file. Okay, so this, and again the Kafka topic is finance topic. Checkpoint location is, I have given the s3 location, s3 column path to checkpoint location or directly. You can give it hdfs also, or any other location or any object storage. So Kafka broker, Kafka topic, and checkpoint location, these three required before proceeding with reading the data. So these are the defining the Kafka parameter. Okay, now coming to reading the data. So df underscore Kafka equals to spark dot, because already created the Spark session, spark dot read stream. So read stream, so normal reading what we are reading, spark dot read, spark dot write. So here we have a spark dot read stream and a spark dot write stream. Dot format equals to the format we are passing the Kafka. The option we have bootstrap server is equal to Kafka server. Subscribe, what we wanted to subscribe, we wanted to subscribe the Kafka topic. Okay, then offset equals to a starting offset equals to earliest. So based on that, either earliest or latest. If you want only latest offset, you can write it latest. Fail on data loss. So why we are using starting offset, fail on data loss also false as true, we will understand later. And then dot load. So if you are doing, so then what it will do, it will load the data to the df underscore Kafka. This is the streaming data. Okay, then again, so this value from in Kafka is in bytes, so we need to cast to the string. So what we have done, df underscore Kafka dot select expression, cast key as a string and value as a string. So whatever the key value pair it is coming, it was earlier in the byte. Okay, so we need to cast into the string, or whatever the desired type you want, you can do that. Then again we are processing, so df underscore kafka dot select key value, so we are selecting the key value, and if any transformation required, we are doing the transformation. So here I have not taken any transformation, I have commented out like add any transformation as needed. Okay, then function to write each batch of data to the postgres. So while reading the data we don't require any batching. Okay, but while writing to the postgres we require the batch. Okay, so we need to write the data in the form of batch. Okay, so df underscore write to postgres, a format equal to jdbc, again the option. So this is the parameter we need to pass for our postgres. So db table is a finance table, suppose username, password. So this everything will be in the vault. So in actual your code, production code, you can't showcase your username, password and everything. These are credential, you can keep it in the vault, and from vault class you can fetch it in your code. Okay, and then mode equals to append. So we wanted append mode because that is the streaming data, so you don't want any data loss. So and dot write save, so it will write to the postgres. And again we need to create a one method, and for each batch, because we are writing the each batch, so set the checkpoint locations to ensure the fault tolerance. So we will write df kafka dot write stream dot for each batch write to postgres. This function we will pass that option equals to checkpoint location, and checkpoint location we will pass under that. So write to postgres function is getting passed under for each batch function. Okay, because of conversion of streaming to batch. Then dot start, then await termination. So why we are writing await termination, what is the use of a check fall on data loss starting offset, we will understand this. Okay, in this video. So df then we are writing df kafka stream, and we are writing, and we are good to go. Okay, now understand the kafka read stream. So dot format equals to kafka. So while reading the data we have write dot format equals to kafka, means we are reading the kafka type of data frame. Option we are passing as a this one. So option equals to kafka bootstrap, like by the kafka broker. Then subscribe equals to kafka topic, subscribe to the kafka topic. Then starting offset equals to earliest, so this specify to start the reading from the earliest available offset. Okay, you can change this to latest if you want to read only the new message. So earliest means you can, so earliest means suppose your starting offset is 0, so it will read from 0. So if you wanted the latest, like you have already consumed your data from 0 to 50, and only left is 51 to 100, so you can you can write it like a latest will, it will take only the latest which is you have not processed. Then fall on data loss equals to false. So this ensure that, so sometime because of some issue like data loss or bad message, your job is getting failed because of this some data loss. So ensure that your stream will not fail if some data losses happen. You can set it true for strict handling. But yeah, if you want like for if any failure happen, any data loss happen, single record, your job should fall, you can make like fail on data equals to true here. Okay, instead of it. So we understand everything under the read stream, like how, why we are using kafka broker, how subscribe topic, what is the mean by earliest, what is mean by latest, and under fail on data loss, why you are making false and true based on data loss. If you wanted to abort your job, or continue with your you can say processing, so based on that we will write like false and true. Okay, now coming to different one, processing the data. So processing here we have not marked any logic. So just we have what we have done, we are just reading the byte data, so we wanted to convert into uh, like a string. So that's why I have casted as a key as a string and value as a string, simple. Now writing to the PostgreSQL. So for each functions, so in what writing to PostgreSQL, what we are doing, we are writing the for each batch. So for each batch function allow you to process each micro batch of data and write to the external system like Postgres. What we understand. So what explained also earlier, like this is the streaming data, but while writing we need we are converting to the batch and then we are writing. Okay, so inside the write to postgres function we have batch df dot write format jdbc. This is all for postgres connection and all, so we can specify the username, password, table and everything. Now coming to the checkpoint location. So checkpoint locations is where the Kafka offset will be saved and then allowing Spark to resume from the last offset in the case of failure. So why we are using checkpoint location? Because if because of certain issue, if our job getting failed, so you don't need to read the data from starting. You can read the data based on our checkpoint location. It will read the checkpoint location. Okay, from starting from till 15th it already consumed the data, then you can start with 51. Okay. Okay. So checkpoint directory can be either HDFC S3 or Dell S3 or any object locations you can write it. So fault tolerance and recovery. So checkpoint help to maintain state between batches. In case of any failure, Spark will recover from the last successful offset stored in the checkpoint directory. Okay. Then triggering and streaming. So dot start begins the structure streaming query. And why we required the await termination. So await termination is required because it ensures that a Spark job continue running until manually terminated. So this is the streaming data, right? So every time the data will come to your offset and you want your job to be continue, right? You don't want to get any data loss. Okay, so because of that you can write like await termination something where so until unless you manually will not pass anything like 400 second or something, 800 or 10 1000 millisecond. So it will ensure that is a Spark job continuously running until you manually terminate. Okay, thank you, thanks for watching.